Hi, I'm Robert Green, and I've benefited greatly from the influence of George and the PGP and appreciate being here. I was interested in the quotes that some of the speakers were making about doctors at the end of the last session. We all know doctors don't have the time or the knowledge. Docs are going to be at the end of the line. I feel a bit like a hacker at a computer security festival, standing up as an actual physician. But rather than get defensive, let me ask you to make a distinction here between types of doctors. Let's take the historical examples of thalidomide, right? It was used by doctors to treat pregnancy in women until medical researchers determined that it caused birth defects. What about frontal lobotomy? It actually won a Nobel Prize for the treatment of psychiatric disease, and we look askance at it today. And even more recently, hormone replacement therapy. Everybody knew it was good for heart disease, right? Until a randomized clinical trial showed that, in fact, it was bad for heart disease. Everybody knew then, well, maybe it was bad for heart disease, but it's good for your memory, good for preventing Alzheimer's disease, right? Until a randomized clinical trial demonstrated that it was bad for your memory, and actually people in the hormone therapy arm were worse off. So what I'd like to suggest to you is that while clinicians are bound by certain structural problems in our reimbursement system and our healthcare system they're frankly quite awful. And it's a dysfunctional system. And you should try to work with them when you can and bring them along as we can. There is another group of physician scientists that sort of get left out of the conversation. And that are those like myself who want to work with the cutting-edge thinkers and the futurists and the biotech companies and those in genomics. And what I call this group in my team is translational genomics and health outcomes, a kind of blend of clinical outcomes research with an awareness of good methodology and an awareness, in this case, of genomics. And I would encourage you to reach out and work with scientists, physician scientists who are in this field, because we are the ones who, I believe, can be honest brokers of the myriad ideas that are being put forward and that have their own potential for risks, costs, and benefits to human beings and society. Now, it's not that we don't have our biases. It's not that we don't have our prejudices and, it's not that we don't have things that cause us to be unfair. But in general, the discipline of physician scientist, I think, will be your ally. And so whether we're talking about incidental findings of the citizen scientist and trying to understand what kind of findings are meaningful and should be given back, I'm part of a consortium that's actually funded by NIH to examine that and to examine it with evidence. Whether we're talking about the risks and benefits and costs of direct-to-consumer testing, I and others are part of a NIH research grant that is trying to fairly evaluate the data on that. And most excitedly, how is whole genome sequencing going to be used in the practice of medicine? The MedSeq project, based right here at Harvard Medical School, is the only federally funded project looking at the outcomes of using whole genome sequencing in the practice of medicine. So we're not resisting. We're with you in wanting to chart the future, and I would encourage you to make a distinction between clinicians and physician scientists and work more closely as partners with the latter. Thank you.
Do you have any questions? Yes.
Hi. Once in a few years, we'll have a $100 genome, and we'll be able to have literally millions of genomes and cross-correlate them with the medical records. Yet there's not the computing capacity to do that. So how do you see that problem being overcome?
I think that computing capacity will grow, and I think that healthcare systems are already developing IT support teams that, they may lag a bit behind the most cutting-edge Silicon Valley thinkers and companies, but they are stepping up to the plate. Here at Partners Healthcare, there is a vigorous understanding and millions of dollars going into upgrading computer support for exactly that kind of research and ultimately clinical biobank.
Somebody at Cambridge Cancer Research UK, who's in charge of bioinformatics there, said they're processing 80 to 100 genomes a month. How do you, even with Moore's Law, where we double our capacity in computer processing every 18 months, in 3 years, he'll be able to process 400 a month. Okay, how do we get to millions?
Well, I don't have the answer to that, of course, but you do, I'm sure you're aware that, if you need to maintain the entire BAM file for a genome, you're talking about one level of storage capacity, but if you only need to maintain the variant file, you're talking about a much more manageable storage capacity. And I guess there are people who are talking about sequencing many times rather than even storing.